Part 284C3M1B7C8E13C9C6D3P38D19D7b9d11. Line 22f1fa19C3M1B7C8E13C9C6D3P38D19D7b9d11. Optomechanical light 5G Wow Seti. There's the alien radio signal. And this is about non-classical light, optomechanical keyword research for a long-distance communications device from the WOW data. March 23rd, 2013. Today's the 27th. The keywords were radiative energy, bilinear form, Fermi line, and Fermi Edge Singularity. Then it went to Mesoscopic X-Ray Edge Problem, Mesoscopic fluctuations in this line of data. Non-classical light Glauber came up. Then I went to Mesoscopic fluctuations, quantum optics, non-classical light, Glauber Sudarshan P representation. Now we're looking at non-classical light and the cavity of optomechanics. Codepedia from a blog, non-classical light generated by quantum noise-driven cavity optomechanics. There's a different scientist. 2012, fairly recent, just under a year ago. Under a year. Wow. Where's the time going? Actually, this is March, so it's not exactly a year. So it's like 5-6 months ago, 7 months ago, something like that. Okay, optomechanical systems in which light drives and is affected by the motion of a massive object. So that's very important because this UFO spaceship engine, the exterior is a massive object compared to what we're going to be putting inside of it. Will comprise a new framework for non-linear quantum optics, with applications ranging from the storage and transduction of quantum information to enhanced detection sensitivity in gravitational wave detectors. However, quantum optical effects in optomechanical systems have remained obscure because their detection requires the object's motion to be dominated by vacuum fluctuations in the optical radiation pressure. So far, direct observations have been stymied by technical and thermal noise. Here we report an implementation of cavity optomechanics using ultra-cold atoms. I was thinking of the cold liquid, the cold plasma liquid argon gas. It's cooled, right? In which the collective atomic motion is dominantly driven by quantum fluctuations in radiation pressure. The back action of this motion onto the cavity light field produces ponder-motive squeezing. We detect this quantum phenomena by measuring sub-shot noise optical squeezing. Furthermore, the systems act as a low-power, high-gain, nonlinear parameter amplifier for optical fluctuations, demonstrating a gain of 20 dB with a pump corresponding to an average of only 7 intracavity photons. These findings may pave the way for low-power quantum optical devices surpassing quantum limits on position and force sensing, and the control and measurement of motion in quantum gases. Figure 1, schematic of cavity and heterodyne detection setup close. And there's the diagram. You can see there. 10% of the cavity output light is diverted to a single photon counting module SPCM, and the remainder goes to a heterodyne detector. All beam splitters are polarized beam splitter cubes preceded by half-wave plates. And it's got the little symbols there. I don't know what those are. I still haven't figured that out. I learned it and then I forget it. So this is figure 2, optomechanical transduction of classical amplitude modulation close. I can't even read it. It says frequency. Frequency and power something. So transduction indicated by the square magnitude of the gain and by the phase offset relative to the drive tone. In the amplitude modulation quadrature, blue squares in A and B. So there's the blue squares. Okay. And drive is maximally attenuated at WM to 26 dB BE. Another diagram. Ponder-motive squeezing in the optomechanical response to quantum radiation pressure fluctuations close. And then we have AB power spectral densities, PSDs, of the optomechanical responses are shown with a common axis at full scale. A, and magnified about the region of shot noise. So that's the magnification of shot noise. In the phase modulation PM red, and amplitude modulation ABM is the blue. Okay. Keyword cavity optomechanics. Source of the keyword is www.nature.com. And it's going to continue in the next video. Thanks for watching.